Hi, we are the Network Aware Container Distribution System team. I'm Purva.
I'm Hao.
I'm Jason.
I'm Tanya.
The goals of this project were to design and implement a system which will make optimal use of the network conditions and enable the peer-to-peer transfer of files over the busy network. The design consists of a master-slave setup. The slaves connect with the master via RabbitMQ, which uses AMQP, that is Advanced Message Queuing Protocol, to send and receive messages. The slaves share their IP addresses and bandwidth information with the master over this queue in JSON format. The master stores this information in the database. We are using MongoDB for our database requirements. Suppose a slave has idle network conditions. The master sends a command to that slave, providing him with the IP and the source in order to start a peer-to-peer transfer. We have used cTorrent, which is an implementation of the BitTorrent protocol. The cTorrent client runs on all slaves. We have used OpenTracker as the BitTorrent server. This runs on the master and supervises the peer-to-peer transfer of files.
Now we are giving a demo of what we have done in this master. Suppose we want to distribute a picture, test.jpg, from the master to the rest of the cluster. The first thing to do is setting up the master environment. We make this procedure very simple. Open the config file on master, modify the path of the file that is to distribute, and the file name. Save the changes and run master in setup.sh. That's it. And wait for it to finish installing RabbitMQ, MongoDB, cTorrent, OpenTracker, and some other Python libs. At the end, we can see that the .torrent file is generated automatically and the master begins to seed others. Now we need to run Python master.py to receive and analyze slave's network condition. the master will send different commands to flows according to what the network condition they are in. What we will show it in a second. Then we need to add a slave to the cluster. So go to the slave node. Like you see, there is no test JPG on desktop. It's a clean node. We modified the config file for slave. Basically, just input the master IP, slave IP, and the download path which you want to store the file you download. Master IP is used for slave to locate the master, and slave ID is used to identify this slave. And now we set the download path which we assume it's on desktop. After saving the config file, run slave in setup.sh to set up environment for slave. In order to let the slave communicate with master using RabbitMQ, we need to go back to master and add the slave ID into master's RabbitMQ vhost. It will be done in just one command. Now we switch back to slave. Everything is set up. We can run python slave.py to send out network condition of the slave. Because this slave is totally idle, the master asks the slave to download the file immediately. Okay, now the test picture is sent to this slave. Okay, now we want to add another slave to the existing cluster. Just repeat the step of adding slave 001. In order to save time, we have set up the environment for this node, slave 002. This slave is busy downloading a Ubuntu image to simulate a busy network condition. We run the slave script. Like you see here, slave 002 is asked to resend the updated network condition because it's busy now. It needs to wait to be kinda idle to get the test picture from the cluster, from the master. Now go back to master. It actually finds out slave 002 is busy and asks slave 002 to resend condition. You see slave 002 is still busy. Okay, it finished downloading. It should be idle now. See, the master detects that slave 002 becomes idle, so it sends a different command, which asks slave 002 to get the test pictures. Okay, this is what we have done in this semester. This program is actually network aware.
What we learned from this project, firstly, we learned the batch programming. It automates the workflow and extremely increases our work efficiency. And we learned the BitTorrent protocol, especially the cTorrent. It's a powerful tool to distribute files within a cluster and utilize the idle network better. And the document-oriented database MongoDB, JSON format, a simple but powerful format for messages, and easy to pack and unpack in Python. RabbitMQ, the AMPQ protocol, it saves us from dealing with the bottom-level network programming, and we can identify message queue by different names for different communication node pairs.